Hello students, let's continue with polynomials, the last section of your chapter, which is algebraic identities. So we're going to look at 8 different identities. The first 4 you've covered in your 8th grade. So there are new 4 that you've got to learn. So what are identities, algebraic identities? They are nothing but expressions that are true for any variables or constants that we substitute in these formulas, right? So let's take a look at them one by one. The first one is a plus b the whole square, which is nothing but equal to a square plus 2ab plus b square, which is square of the first term, square of the last term, and 2 into the product of both the terms, right? Second one is a minus b the whole square, which is a square minus 2ab plus b square. So if you see, both of these are almost similar. However, there is a difference of sign. That is why the sign here is changing, but not for the last term. Only the sign in the middle changes for this. So you see, I have marked these. Why? Because you can refer to them as partners, right? Because they are almost the same except the difference in sign. So the terms are the same, right? A square, 2ab and b square, okay? Now the second one, a square minus b square. I'm sorry, this is the third identity. A square minus b square is a plus b into a minus b. Now notice that this is different from this one. Why? Because this is a minus b the whole square, whereas this is a square minus b square. So a minus b the whole square, when you expand it, you get this term, right? It does not give you this term. For this term, we have a different formula altogether, right? Now let's take a look at the fourth identity, which is x plus a into x plus b. So here the first terms are the same, but the second term in both the brackets are different, which is why I cannot take them as a plus b or x plus a the whole square. Why? Because we have 3 different terms. So now what is the formula for this? It is x square plus a plus b into x plus ab, right? Then we have x plus y plus z the whole square. Like we have a plus b the whole square, we have x plus y plus z the whole square. You could even write it as a plus b plus c the whole square. So now there were 2 terms here, however we have 3 terms here. We just have to square. So squaring this is similar to this one, but let's see, there would be difference in the terms that we have. Since we have 3 terms, we are going to square them individually, which is x square plus y square plus z square. Right? So this is similar to a square plus b square, right? But we have 3 terms, that is why square these 3 terms. Then we have 2xy plus 2yz, I'm sorry, 2yz and 2xz, right? Like we have 2 terms, we have 2ab. Now we have 3 terms here. So we are going to pair the 3 terms. Like how? You have a, b and c. So a goes with b and a goes with c. So oh, sorry, let this be x, y, z, so explanation is simple. I have x, y, z. So I'm going to pair x with y and x with z. So I get x, y and x, z, right? And then I pair y with z. I'm not taking y, x because y is already paired with x. So y, z, right? Now a plus b the whole cube and a minus b the whole cube again are partners. Why? Take a look at this. They are similar. Similarly, these 2 are similar with a difference in sign. The numbers, the terms will be the same, okay? So a plus b the whole cube is a cube plus b cube plus 3ab into a plus b. So the cube of both the terms plus 3. Why? Because you have 3 over here, so 3ab into a plus b. Now let's compare the 6th identity with the first one. Since this is square, I'm squaring both the terms a square and b square. Right? So a cube and b cube. Then you have square here, which is 2. So 2ab. So I just have 3 here because I have cube. 3ab into a plus b. So we do not have a plus b inside here. The extra addition is a plus b only. And I'm taking 3 instead of 2. Right? Now a minus b the whole cube is a cube minus b cube minus 3ab into a minus b. Right? So the terms are the same, however there is a difference in sign, right? The last identity, which is the 8th one, is x cube plus y cube plus z cube minus 3xyz. So how are we going to solve this? This is x plus y plus z into x square plus y square plus z square minus xy minus xz minus yz, or minus xy minus yz minus xz, right? So we have these three terms, adding these, then I'm taking another bracket, product of square of these terms minus taking like how I solved here, we had x, y and z. I'm pairing xy and xz, xy, xz and yz. However, this is getting subtracted. So even though we have positive here and negative here, that's why we have positives and there's a negative here, right? Now let's go ahead and solve certain examples of your textbooks. So let's take a look at example 17, that is solved example 17. Find the following products using appropriate identities. So using these identities, I am going to solve these two sums. Now x plus 3 into x plus 3. So x plus 3, both of them look similar, right? So if this was an apple, this was an apple. So apple into apple is apple square, right? Now if I would solve this using the traditional method, it would be something like x into x plus 3 plus 3 into x plus 3, right? I'm taking x, then multiplying it with this bracket, then plus 3 and multiplying with these brackets. This is not the wrong way of solving. It would give you the right answer. However, it would lead to many terms. 2 terms here, 2 terms here, 2 terms here, 2 terms here, 8 terms, and then you have to add. So it would be very tedious and increase your number of steps, as well as your efforts, very time consuming, plus you might get bored. So which is why our mathematicians, they have introduced these identities so that your efforts are reduced. So let's see. Now x plus 3 into x plus 3 can be written as x plus 3 the whole square, right? So this is similar to which identity here? Take a look. The first one, right? So using identity 1, what do I get? X square plus 2 into x into 3 plus 3 square, right? So this is a plus b the whole square, suppose. So a square plus 2ab plus b square. So x square plus 2 into x into 3 plus 3 square, right? This is equal to x square plus 6x plus 9. Box your answers. Very good practice. Leaves a good impression on the examiners. So using identity 1, I have solved the first sum, right? Now let's go ahead and solve the second one. We have x minus 3 and x plus 5. So does this expression look similar to any of the identities here? Take a look. Well, no. So does that mean that we cannot solve this using an identity? Well, that's not the fact. Let's see how. We can write x minus 3 as x plus of minus 3, correct? Then we have x plus 5. Does this now resemble any identity here? Take a look. I see that it does resemble identity 4, which says x plus a into x plus b is x square, then the sum of the two terms into x plus a into b, that is the product of these two terms. So let's solve this. You have x square plus minus 3 plus 5 into x plus minus 3 into 5, right, which is equal to x square. Let me write this in a more compact way. It looks too big. I did not write it wrong, just writing it more neatly. I have x square plus minus 3 plus 5 plus minus 3 into 5, right? I'm going to solve the ones in the brackets here and this one as well, right? So I'm solving the brackets first. So I get x square plus minus 3 plus 5 gives me 2. Here I missed out an x over here. A plus b into x, right? So 2x and plus minus 3 into 5 gives me minus 15, right? So opening the brackets, I get x square plus 2x minus 15. This was using identity four, right? Box up your answers. So using identities 1 and 4, we have solved the first two examples of your last section, algebraic identities. We will take a look at the rest of the examples as well as exercise 2.5 in the forthcoming lectures. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.